everyone. This video would show the easiest way to simplify radicals with variables, and this is the third part. In this part, we're going to simplify fourth root and fifth root expressions with variables. Before we go further, please feel free to check out the description below for the link of the other series of topics related to simplifying radicals with variables. Before we write into this example that we have right here, let's have a review on the parts of radical expressions. Please remember that these are the parts of every radical expression. The first part is the radical symbol. The reason why this is called radical expression is because it is an expression that contains the radical symbol. Our a here is called a coefficient. A coefficient is a number multiplied to the radical expression. And the letter n here is called the index. This tells you which root you're looking for. Please remember that if the value of the index is not written in there, it means that that invisible number is 2. We also have a letter C, and this letter C is named as the radicand. A radicand is the value that you are taking the root of. So this expression that we have here is read as A times the nth root of C. Okay, we go over the problem here. In order that we can simplify this expression that we have right here, the first step is to expand the given expression. So I'm going to go ahead and write the radical symbol that we have right here. That is the fourth root. And so we go ahead and start by expanding 54 to its prime factors. So I'm going to go ahead and show that work on the side right here. So we start with 54. And then we divide this. Again, the trick here is divided by 2. So that would be 2 times 27. That's 54. And then 27 is not divisible by 2, but it's divisible by 3. So that is 3 times 9 is 27. And 9 is divisible by 3. That's 3 times 3. So these numbers that we have here are the prime factors of 54. So we go ahead and write that on the side here. So that would be 2 times 3 times 3 times 3. So there's like 3 3s here. So this is the expanded version of 54. Now we are going to expand the x to the 7th as well. So I'm going to write 7 x's. That's 1, 2, 3, 4, 5, 6, and 7. So this represents the x to the 7th. Now the second step is to group the expanded form based on the index. Since our index here is 4, we are going to create a group of 4. So in this case right here, we can create a group of 4 2s. There's no 4 3s here. However, we can come up with 4 x's, and this is the only one that we can group together. Now we remember that when we simplify it, we are going to write those group of 4 based on the index outside the radical symbol. So there's like one group of 4 x's. So I write x, and then whatever's the leftover, we write it inside the radical. So that is the fourth root of 2 times 3 times 3 times 3 times x times x times x. So this, what I did was I write this group of 4 x's to just 1 x, and then I wrote this 2, 3, 3, 3, and this 3 x's as well. So that we go ahead and simplify this further. So this would come out x times the fourth root of 54. That is the fourth root, and then this is x to the third. So this is the simplified version of the fourth root of 54x to the fourth. Now, please remember that we assume here that our variables are positive or having a positive value. Now, let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, our first step is to expand the given expression. So I'm going to go ahead and write that radical symbol right here. So that would be 4. So we're going to simplify this 160 or expand this 160 to its prime factors. I'm going to show the work on the side here. Okay, so these are the prime factors of 160. So I go ahead and write these prime factors on the as a radicand right here. Okay, I also have to expand this 2x's, so that would be 1 and 2, and then I'm gonna expand this 7y's as well. Okay, our next task is to group them together based on their index here. So we have here 4, so we're gonna look for groups of 4. So there are 4 2's here, so I will take this as one group here. We cannot have 4 5's. There's no 4 x's, but we can group together the y's here. So there's gonna be 4 y's as well here. So we go ahead and write those that we group together. So group of 2, so I'm going to write 2. We put it outside the radical symbol, and then we have another group of y. And then whatever's the leftover, we are going to write it inside the radical symbol. Okay, so what's going on here is that this group of 4 2's, I wrote 2 here. This group of 4 y's, I wrote the y. And whatever's the leftover, I write it inside the radical symbol. So we can go ahead and simplify this further. That would be 2y. Fourth root of 5 times 2 is 10. There are 2 x's, that's x squared, and there are 3 y's. And again, this is to the fourth root. So this is the simplified version of fourth root of 160x squared y to the 7th. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to expand the given expression. So I'm going to go ahead and write that radical symbol right here. Please remember that this is to the 5th root. So we are going to expand 96 to its prime factors. I'm going to go ahead and show that work on the side here. Okay, so these are the prime factors of 96. So I'm going to go ahead and write those prime factors on the side right here. So I wrote these prime factors on the side here. I am also going to expand this x to the 5th, y to the 6th, and z to the 7th. Okay, now what I need to do is to group together the expanded form based on the index. And since 5, I'm going to look for groups of 5. So in here, we can come up with 5 2's here. So this will be taken as one group here. And then I'm going to group the x's together. 1, 2, 3, 4, 5. So there's like 5 of them. And then the y's here, 1, 2, 3, 4, 5. So I'm going to group together those 5 y's. And then for the z, 1, 2, 3, 4, 5, I'm going to group them together. And so these are the groups of 5. I'm going to go ahead and write that outside the radical symbol. So there's like one group of 2, and then there is another group of x, and there is another group of y, and there is another group of z. And I am going to write the ones that are left over inside the radical. So we get a 3, we get a y, and then we got 2 z's. So I go ahead, again, we remember that this 2 here comes from this 5 2's here. These are the 5 x's, these are the 5 y's, and these are the 5 z's. And these are the leftover 3 y and 2 z's. So I go ahead and simplify it further. So this would come out 2 x, y, z times the 5th root of 3 y z squared. So this is the simplified version of the 5th root of 96 x to the 5th, y to the 6th, z to the 7th. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!